It's not Starry Night tattoo.
Oh, Starry Night. Some people like, some people love Van Gogh. Van Gogh is a good artist. Hi everyone, it's October 29th. Alright, let's shake off the rust. I didn't do very well for the past maybe 3 days. Alright, let's see what we have today. Rotting oranges. Alright, so what we have. I have not done this before. I'm pretty sure. Because if I had, I would have remembered the title. Well, you're gonna be hurt, right? You're gonna take tattooing on your head, on your scalp. I just said I didn't do it before, and then boom, right there, I did it. 2020, August. All right, let's take a look. See if I remember it. M by N grid. Okay. Each cell can have one of three values: 0 representing empty cell, 1 representing a fresh orange, and 2 representing orange, rotten orange. Every minute, any fresh orange that is full directionally adjacent to a rotten orange becomes rotten. Ah, now I remember it. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If it is not possible, return -1. So, 1 minute I got these two. 1 minute I got these two. 1 minute I got this. And 1 minute I got this. And this one I have one orange that doesn't have. Okay. It's a 10 by 10 grid. So we can basically just scan through everything, and at each iteration, right? At each iteration, we whatever is rotten, we just get the next one, right? And then whatever's rotten, get the next one. That will definitely work, right? That will definitely work. And if no orange is rotten in one iteration, that means we have hit the end. And we need to know how many oranges are rotten. So, okay, so how do we know that if there's anything that's not rotten? I mean, we can just go through again, do one more traversal to check. All right. Okay. Yeah, that's possible. That's possible. Yeah, let's just try that. I think it will work, but it's probably not the smart solution. Let's just get it first. Let's get it first. So basically, what we're saying is at each iteration, right? We want to see if there is each iteration, we're looking for a fresh orange. Right, that will be easier. Each iteration, we look at a fresh orange, and we'll see if anything, I think the previous one is like adjacent ones, right? Adjacent ones is rotten. If it is, then we turn that into rotten. Oh, that might have an issue. We might need to copy it. No, we don't want to copy. We'll set a new value. Because, let's say, we're looking for a fresh orange, right? And look around, oh, this one is rotten, and I set it to rotten. But then, if I look in this one, it will say, this is rotten, now I'll turn myself to rotten as well. So no, if I'm rotten in the current stage, I need a new value to represent it. So in the next stage, anything then we turn it. Yeah, and then if anything, look around. So the only way that I do not turn rotten is if the surrounding is either 0 or 1. If the surrounding is not 0 or 1, then I'll turn rotten, whether it's going to be a 2 or it's going to be another value that I'm going to use, like a -1 or something like that. And if a thing is a -1, then I'll immediately turn it. Yeah, that shall work. So, we're gonna say, we gonna say? We're gonna say res, right? Res can be 0, and we say for no while true, right? While true, and then we end if nobody turns rotten. So has a turn rotten. Rotten is going to be a flag. I'm going to say false, right? And then for row in grid, right? We'll probably I row in enumerate grid. It'll be easier. Let's do it easier. Just say mn equals len grid and len grid 0. That'll be easier. So for I in range m, j in range n, right? And we say if grid ij is equal to -1 grid ij. Actually, I don't need to. No, I do. So grid ij is equal to 2, right? That's rotten. Elif grid ij is equal to 1, which means it's fresh, right? Which means it's fresh right now. Now we need to look around, right? We need to look around. But if I look around, there's an issue. Like, if I have a thing that's rotten in this round, but I set it to -1, in the next round I check this one first, and I see this is -1, and I don't turn. That's the problem, right? That's the problem. How do we avoid that problem? Because it currently is not 2 yet, and I cannot set it to 2, right? If I set it to 2, then this one will go to 2 as well. But if I don't set it to 2, in the next round, then we have issue. So how do we know that once we set it to 2, then this one shall not go? So basically, it's a question: how do I signal that the current rod, right? The current rod is the current round, so we will not handle it. How do I know it's the current round? Current round. I mean, we do have a round. This is round, right? This is the round. So if the value is indicative of the round, then I know. Like, if it turned in the previous round, okay, that is a thought. How do we implement it so that I know which round it is? Well, the current round is represented by res, right? How about each time we go res, it's going to be plus equal to 1, right? Plus equal to 1. So if I go the negative on the res, right? If we go negative on the res, let's say res start with 1. It doesn't really matter where res start, right? It doesn't really matter. So let's say res start with some value. Let's say just say res starts with 3, right? So because 3 is not included in this, and so every time, right, when we equal, it will equal to we turn into 3, right? This one will turn into 3. Actually, no, we turn into 3, yes, and then we check it's the current round, so we don't turn. And if it's the next round and we turn, that seems to be more likely. So, and that actually means if I turn into a value which is equal to, let's say, some arbitrary value, and then this is the same round and I don't turn, but I don't have to change this value again because in the next round, the rest will go higher. So then we know this is turned previously. So yeah, so if I don't have to do this, right? I just say if current is a fresh, and I'll look around. Let me say for new I, new j in so I plus 1 j, right? I minus 1 j, and then I j plus 1, and I j minus 1. So that's the 4 directions. So the 4 directions, if ni equals 0 smaller equal to ni smaller equal to m and 0 smaller equal to nj smaller to n, then we're going to check. We say if grid ni nj, right, if that is smaller than current res. I shouldn't say res. Let's name it something different. It's just what should I name it? It's gonna be res and I'll just call it temp so I don't have to think. Right? So if it's smaller than temp, if the neighbor is smaller than temp and larger or equal to 2, right? So if it's 2 and this smaller than temp, that means it is rotten in the previous, right? It's rotten in the previous, so let me say it's rotten in previous rounds. So if that's the case, then I will turn rot, and I will rot. So I say this will equals to temp, right? I will rot. And if it's smaller, then we do not rot. And if we rot, then rotten will equal to true, right? So when I go through all this, right, go through all these shenanigans to get all the rotten ones, and then when I check, right, if not rotten, if nothing's rotten, then we're going to break. Otherwise, when I say temp, I'm going to plus equal 1. So that's the next one. So afterwards, we're going to say when the return temp minus res, right? That means we have if temp is larger than res, else minus 1. Okay, so let's try this. So first test case, I have grid. This answer is 4. All right, next one is this. Answer is minus 1. Hold on. No cell has fresh if it is possible. So that's actually not, because we want to see if any cell, which means if nothing is rotten, then we return, right? Shouldn't we also keep track of the number of fresh ones? Yeah, we need to track the number of fresh ones. Number of fresh ones. Nothing gets rotten, and now we break. But we also need to track the number of fresh ones. Right? How do we track that? So we need to have rotten and number of fresh 0, right? And every time is 1, then number of fresh also equal 1. And we shall return this if not number of fresh, else, yeah, that shall be right. We need to count the number of fresh ones. Already no fresh orange, number 0. The last one is 0, 2, 0. Okay. Grid, and this is going to be orange rotting grid. Yep, this one seems to be right. All right, let's try it. Yep, that's about right. So let me check what we have previously. And the same time as this one. Time tick. I check the number of fresh, and then rottens pop left. I use a deck. Hold up, what was I doing? I put all the rotten ones, I check the number of fresh. We say while rotten and number of fresh. I go through all the rotten, I get it, and then blah 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 blah, I turn new rotten, and number of fresh minus, and grid equals to 2, and then number ticks. It's a different technique, right? This one, I have a queue of rottens, right? And I also keep track of the number of fresh. So I'll say this one will go if there's no fresh or there's no more rottens. Yeah, so no more that I can go rotten, because every time I will pop the rottens, and then we check surroundings, and we take surroundings that I can turn into. I turn into rotten and push it back in rotten. Number fresh minus, and then time tick, blah blah blah. At the end, when it gets out, either we don't have any more to rot, or we don't have any more freshes. And then when I check number fresh, okay, that's fine. That's a solution. Now this one is slightly different, right? But this one we use a technique, because I think I used it, and then this probably I get it from the solution. Let's see, an original, like very first solution. That's probably slightly different. Maybe I copy. Refreshes, time tick, has rotten neighbor. I upgraded the grid. Anyway, so let's focus on this solution. So this one, I think the main contribution, right? The main thing. Nice, you recognize that. Yeah, that's actually a good handwriting too. Oh, they probably just printed. Means the person is very family oriented. Well, 家人 is family member, but 家 is family. 家 is home, but home, right? Home is family. It has extensive meaning. All right, so the main, how should I put it? The main trick in this solution, right, and then the main problem, right? The main problem is how do we identify, how do we tell that an orange is rotten from the previous round, or from the current round? Yeah, that's the question, from the current round, right? If we are at a fresh orange and its neighbor has just rotten, right, in the current round, then we should not rot the orange. Otherwise, if the neighbor has rotten in previous round, then we shall rot as well. To resolve this issue, we use a temp value to indicate at which round an orange has rotten. Thus, if a fresh orange, right, if a fresh orange sees that its neighbor is rotten in the same round as itself, as in the same round as right now, it does not rot. Otherwise, it does. Now, the reason that I put quotes on round is that the temp value is not strictly the round. It starts from 3 and going upwards. Now, the reason that we cannot start from 0 because 0 and 1 have different meanings. At the end, we can compute the number of rounds by doing temp minus res. Also, we need to keep track of the number of fresh oranges and whether any additional orange has rotten. If there is no more fresh orange, if there is no more new orange, no more new rotten orange, that means we have terminated. All right. It is also worth checking my solution from more than a year ago, where we use a queue, right? We use a queue to keep track. We use a queue and a global count of fresh oranges to keep track of the current state of the grid. Anyway, this one runs in OMN. Wait, they say it's a square. No, it didn't say it's a square. So OMN and it's called iterations, rounds, right? Where M, N are the dimension of the grid, and R is the total number of rounds. And running 52 milliseconds, which is actually exactly the same as we had last time, 79%. Alright, I don't think we need to take a look at other solutions. That shall be it for this one. Alright, I think we have time. Let's roll another one. I'm in the mood. Let's see, what do we have? All right, let's roll another medium. Minimum length of string after deleting similar ends. Okay. Nope, not done this before. Okay, given a string S consisting only of character A, B, and C, you are asked to apply the following algorithm on the string any number of times. Pick a non-empty prefix from the string S, where all the characters in the prefix are equal. Pick a non-empty suffix from the string, where all characters in the suffix are equal. The prefix and suffix should not intersect at any index. The characters from the prefix and suffix must be the same. Delete both the prefix and suffix. Enter the minimum length of S after performing the above operation any number of times. You can remove C, A, B, and A. We can remove A. It doesn't say the same length. Just non-empty prefix and non-empty, so AA and A, B and BB, and that's it. A in the front A, B and BB, and that's it. 2 hints. Alright, so most likely the first thing in my head is 2 pointers, right? So we have 2 pointers, and we're gonna go as much as we can on the front. Well, first we need to check if the front and end are the same. If they are the same, then we go as much as we can. Right, because to the minimum length, I think it's going to be greedy. Alright, because we can pick any. So let's say if we don't pick the entire sets of the same, we just pick like a little bit, then it is possible that the next one we look at will not be the same. Then we cannot remove anymore, right? So it's not possible that. So the optimal is to pick the entire stretch of the same characters at the front, and the entire stretch the same character at the end. We cannot pick and choose. Yeah, I think that is the case, because if we pick and choose how many would do, yeah, let's say if the pick and choose give us the shorter, right? And it cannot give us a shorter, because I can always go more. And the prefix and suffix should not intersect at any. So just out of curiosity, let's say it turns 0. I want to see. Let's say this, right? What does this one have? It should be 0, because I can pick one. I can pick one. Right? What if I have this? Good question. 1, because I cannot pick. Right? Yeah, I cannot pick, because it has to be non-empty. It has to be non-empty, so I have to move. And they cannot be the same. Okay, so let's try. So that's gonna say copy. All right, this is what? This is 1750. So it's T 1750. All right, let's try this. All right, so we have a low and a high equals 0 and the len is -1, right? So that's what we start with. And we say while low is smaller than high, because they cannot be the same. So while low is smaller or equal to high, and we shall return So blah blah blah, and at the end I'm going to return high minus low plus 1, right? So remove, and then we'll add it here. Yeah, so okay. While this and S low must be equal to S high, right? If they are not the same, then we cannot remove. So this is this, and then we're gonna say while low smaller than high and S low is equal to S low plus 1, while low plus 1, right? Then low plus equal 1 until so low equals low plus 1, right? And it's good, I move. If low is not equal to low plus 1, then we stop, right? Then we stop. So this one will have them stop at the position. I don't want them to stop at the position. It's fine, it's fine. So we do this, they just go through. So it's going to be while high minus 1 is larger than low, right? And S high is equal to S high minus 1. Then high minus equal 1. So we're skipping all the same. And then the last, we're gonna get into the ones that's not the same. I'm gonna go again. Okay. Let's do this one short. We have CA. CA shall return 2 because we cannot do anything about it. This will give us 0 because we can remove everything. And this will give us 3. And we have a couple more. We have A will give us 1, right? And the AA give us 0. And AAA shall be 0 as well. I'm pretty sure AAA is 0 as well. This is, yep. Run it. Oh, I think we got it. Alright, let's try this. Submit, pending. Got it. 51%. But this is so we use 2 pointers, right? 2 pointers. We use 2 pointers, and we move the pointers towards the center. At each moment, we check whether the values at the 2 pointers are the same, right? Are the same. If they are not the same, that means we cannot proceed anymore. If they are the same, then we skip all the duplicates, right? All the duplicates, and land on a new letter. Then we skip all the duplicates for both pointers and land on new letters. And then we continue. So this one will return it's going to go ON and 116 milliseconds or 51% ranking. Let's take a look. Take a look at what smart people say. And also, let's see, 96. C while this and this, C is this, while I is smaller than J, this is equal to C, blah, 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 blah. I is smaller equal to J, and SI is equal to C, and that's how you move to the next one. Oh, I see. That's how you move to the next one. You set this aside, and you do this, and then you can move to the next side. This one, it's just low plus 1, right? So I cannot go the low over, so I have to do this one more time. That's fine, it's the same. Right? It's the same idea. 2 pointers, easy and concise. What? What is this? Oh, it's stripping. While this is larger than 1, and front and end is the same, I'm going to strip. That's a good question. Bad test cases. Yeah, it's probably bad test cases. String generation is fast. Keep reviewing your codes after writing. Oh, wow. Yeah, this is not ON, but I'm gonna like it. Yeah, using strip. I mean, let me see. Python. Yeah, strip. Yeah, it can strip a given string, right? It doesn't have to be. Yeah, here's the documentation. Strip. So strip. No. Oh no, this is string constant. str.strip. And then a copy of the string with the leading and trailing characters removed. The char's argument is a string, specifying the set of characters to be removed. If omitted, the char's argument defaults removing white spaces. The char is not a prefix of it, rather all combinations of its values are stripped. So all combinations of the C, O, M, W, Z. I see. So all combinations of this, and this, so all these are removed. Empty are removed. So this is. I think there's a new one, right? I think there's a new one that does a specific prefix. Oh wait, isn't it has a prefix? Isn't that in 3.10? Bit count. No. I don't think that's it. Wait, what is the Python strip prefix? I think there's a new. Oh, there is. Look at here. Remove prefix, remove suffix. Remove prefix, remove suffix. Hold on. So it's remove prefix. Is it in? Where's the documentation for this? No, I don't want a pep. I want a building method. Remove prefix. There we go. Oh, there's an else strip and a remove prefix. It's all combination, right? Else strip is all combination. It's not a prefix, it's a combination of it, but that will remove a single prefix string rather than all of the set of combinations. Else strip, a combination of all this. So T, H, R will all be gone, but this one will remove this. There we go, remove prefix. It's new in 3.9. Remove suffix. I see. Okay, so yeah, I've been lazy. Let's just call it a day. I'll save some energy for tomorrow. 2 questions is good. Alright, that'll be it for today. I'll see you guys tomorrow. Adios.